Narrator, the Great Pyramid of Giza, the oldest and perhaps most perplexing wonder of the ancient world. 2.3 million blocks. The average weight? 2.5 tons. Moving just one seems like a physical impossibility.
For millennia, we relied on speculation. Simple ramps, simple sledges. But modern physics shows us they all fail.
The straight ramp? Too long. The spiral ramp? Too unstable. There is no evidence for these grand solutions. On dry, loose sand, a 2-ton block requires thousands of men just to overcome the static friction.
The answer was hidden in plain sight on the walls of an 11th dynasty tomb. It's an engineering manual.
A large statue on a sledge. But look closely at the man at the front. He is pouring liquid onto the sand.
For years, we called it a ceremony. But what if that water was the actual technology?
Sand is not ice. Too much water creates mud. The secret lies in a perfect ratio.
We need to move beyond theory. Let's test the force on dry sand versus optimized wet sand.
Test 1. Dry sand. The sledge digs in. The resistance is massive. Test 2. Optimized moisture. The force required drops by 66%. The sand is now a solid road. This is the core principle. Capillary bridges. Microscopic water tension locks the sand grains together.
Precision is everything. The optimum range is narrow, only 1 to 5% water by volume.
Can we validate this breakthrough on a pyramid scale? We turn to our AI modeling system. At 4% water, the block can be moved by only 10 workers instead of 200.
This isn't a trick. It's a mastery of soil mechanics. Their secret tech was applied physics.
The man pouring water was the most important engineer on site, precisely controlling the moisture path. By solving friction, they eliminated the bottleneck. They turned the impossible into the routine.
It wasn't wheels or anti-gravity. It was an intuitive mastery of the natural world.
A civilization that solved the problem of scale by first solving the problem of sand.
But what about zero-point energy?
To grasp the scale, we must analyze the quarry, a journey of miles for every single block. Thousands of men working with limited tools. The challenge was sourcing the raw materials. Water transport via the Nile was manageable. The critical phase was the final land transport across the plateau.
Every millimeter on dry sand is a battle. You aren't just fighting weight, you're fighting the grains.
In a dry sand scenario, the work rate is 0. The logistics are unmanageable for any project manager.
The solution isn't more force, it's less resistance. This is our enemy, the coefficient of friction. On dry sand, it's a physical wall.
We have to change the behavior of the medium itself.
Wetted sand resists deformation. It acts as a temporary solid under pressure.
Modern researchers at the University of Amsterdam decided to stop guessing and start measuring. The data was conclusive. At 4%, the sand surface behaves like a paved road. Water doesn't lubricate, it creates an adhesive bond.
These tiny water bridges are strong enough to withstand the pressure of a 2-ton sled.
This man was a human hygrometer, gauging the sand's thirst with incredible accuracy.
For 4,000 years, this was dismissed as decoration. It was actually the blueprint.
This simple act changed the economy of labor forever.
Now, we scale up. We feed this data into the AI to simulate the entire 20-year project.
The AI confirms it. The construction timeline becomes statistically plausible with low friction.
The water requirement was low enough to be logistically feasible. It was a calculated use of resources.
10 men moving a 2-ton block. The secret was embedded in their daily routine.
They didn't need to defy gravity. They just manipulated the forces surrounding them.
A monument not to brute force, but to intellectual elegance. Our journey into history confirms that the greatest mysteries are often just overlooked evidence. The physical proof remains in the sand. True power lies not in machines, but in the knowledge of how the world works. True power lies not in machines, but in the knowledge of how the world works.
In 2014, science finally caught up with the 11th dynasty.
Meticulous control was the key, finding the tipping point between dry resistance and mud. The line drops at 4%. Go past 7 and you are back to total failure.
This tiny window is the difference between movement and disaster.
When oversaturated, the capillary bridges rupture. The sand turns back to mud. The water pourer's technique was an empirical masterpiece.
Solved the horizontal move. But what about the incline?
On a 20-degree slope, gravity fights back. They needed a force multiplier. Evidence suggests they used anchored posts, looping ropes to multiply their pull. This mechanical advantage turned the horizontal solution into a vertical transport system.
Wear patterns on recovered wood match this stress. They were master rope handlers.
Integrating sand physics with mechanical levers created a functional, scalable system.
The secret tech was a fusion of microphysics and macromechanics.
A story of human ingenuity confirmed by AI. The impossible made possible. Control of moisture was a logistical triumph dependent on the Nile's flooding cycles. Temporary canals brought the water directly to the haulage tracks.
The materials were as engineered as the pyramid itself. Cedar and acacia, treated for the wet sand.
Braided plant fibers handled the extreme tension. A single break could mean catastrophe. On dry sand, these ropes would have snapped under the strain.
This allowed them to focus their complex resources on the lift, not just the hull.
To sustain the pace, work continued through the night, keeping the tracks damp. Our AI heat maps prove this optimal corridor was the logistical spine of the project.
Friction solved, gravity solved, the impossible became inevitable.
Not monuments to magic, but to human perseverance and understanding.
If the Egyptians mastered sand, who mastered rock?
We cross-reference LiDAR data to confirm the absence of alternative large-scale ramps. The physics model is absolute. Tension over friction. The initial transfer from the quarry was the first step of the journey.
The sledge runners were optimized to glide, a perfectly integrated system.
Throughput rates of 200 blocks a day make the timeline feasible.
The mystery is validated. The wet sand model stands as the definitive answer.
Success hinged on a constant, regulated flow of water. A society organized around physics, a testament to human capability.
Sometimes the greatest genius lies in the elegance of the simplest solution.
The capstone rests. The secret is revealed.
If they mastered the desert, what did they master under the waves?
Satellite imagery confirms the minimal debris left by this efficient model. Maintenance was as vital as the pulling. Every dry patch was a risk. The genius of the 4% solution avoided the trap of mud.
They understood the behavior of water and soil implicitly.
A triumph of organized labor and scientific application.
The 20-year timeline is no longer a myth. It is a calculation.
Holistic engineering, designed for guaranteed high-volume efficiency. Their assembly line, utilizing the sand's physics against itself.
The pyramids show the capacity of the human mind to observe and innovate.
History has countless more whispers to share, waiting for modern science.
Who mastered the flawless fit of these stones?
Rations and records align with our low-friction model. Each segment was treated like a precision road. Low friction meant less wear on the wooden runners and the ropes.
We now have the science to separate the myth from the mechanism.
Sustainable effort versus exhausting strain. This was the gift to the workers. The secret was held in a single drop of water. Why the Egyptians had the secret tech.
How did they achieve this with stone hammers? If it wasn't water, was it sound?